Hey guys, picking up where we left off, this is number 5 on test number 1, test review. It says, a person is walking across a hanging bridge suspended over a river. So pretty much for all application problems, guys, quadrant 1 is the most important quadrant, okay? It says a hanging bridge droops in the middle, creating a parabolic shape. So let's say we got a bridge that we're going to walk across that looks like a parabola. The distance in feet from the person crossing the bridge to the river at any point can be described by the expression 0.02x times the quantity x minus 100 plus 110, where x is the horizontal distance the person has walked from one side of the bridge. Interpret the factors in the context of the situation. So what I'd like for you to do, guys, is if you could remember that on the second day of class, let me try to find the worksheet. We did an exercise where we were given points or given different information and had to be able to write the function. So one of those involved a transformation of factored form. So let's see if I can pull that real quick. And of course I can't find it right now. Okay, so I'll just show you one. So if given the points, and this is just a refresher, if given the points 4, -2, and 4, 3, I'm sorry, wrong points, let me switch those around. 3 and then -2, we can actually recognize that if we were to graph these, and 3, -2, that they're only one away from the x-axis. So I taught you that you could take the x values and write it in factored form, meaning we could write a function f of x equals the quantity x minus 4 times the quantity x minus 3, and then just shift all the points up the same distance or down the same distance. So because these are only down 2, I'm sorry, these are down 2, not down 1, then we can just simply put the y value at the end, and that would be a transformation of factored form. Well, if you take a look at this factored form here and here at this function, then you would see that it kind of looks similar. You have two factors and a constant at the end, which would be the transformation, meaning all points from this graph would be shifted up 110 units. So what in the world does that mean? It means that if we think about what these two zeros are for this expression, and because we have a monomial, that would be 0. Well, where do we get that? Remember, in factored form, you always set the factor equal to 0 and solve. But what we've been doing is just doing it visually. Here, we would just look at it and say, oh, that's 100. But whenever you have a monomial, understand that it always will hit the x-axis at 0. So if you think about the fact that it says where somebody crosses the bridge, so if you think about somebody moseying on the bridge, coming down here and going to here to cross over the river, then the x-intercept would be 0, and you would have another x-intercept at 100. Well, how far away is 0 to 100? Well, it's 100 units, right? Distance of 100. But it says up here, let's see, that, oh, by the way, if we were to simplify this out, we would have a constant of 110. How do I know that? Because if I distribute this right now, I would have 0.02 x squared minus 100 times 0.02, which is 2. So minus 2x, I'm done distributing, plus 110. So I know that's my constant term. So that means that the y-intercept of this bridge is 110. So now it just says interpret the factors in the context of the situation. Well, if you think about recognizing that the factors give you 0 and 100, as zeros, and that we can relate the translation of this graph. So what I'm saying is, if it was at 0, 100, if that was the bridge, we would say that the bridge has a horizontal distance of 100. Now, granted, if somebody's walking along this bridge, they're going to walk a little bit longer than 100 if the bridge was stretched out, but it's not. It's a horizontal distance of 100. Well, all this function represents is that this here is shifted up 110. So really, what's going on? You got a river. You got a river under the bridge. The bridge is 110. The start of the bridge is at 110 feet off the ground. And what did the factors tell us? The factors told us 0 and 100. So that means if our 0 is shifted up here, that would be the ordered pair 0, 110. And this ordered pair would be an x value of 100, 110. So what does that tell us? It tells us the horizontal distance of the bridge itself is actually 100 feet. And that's what I would want you to state. The horizontal distance of the bridge is 100 feet. Why? Because the zeros were 0 and 100. Okay? So this is kind of the why behind why it works. Understanding that factored form, that if you've got two ordered pairs with the same y, they can be written as factored form and translated, just like I taught you. I think it was like the second day of class, maybe. But that we can use that understanding to understand the form that this is in. Okay, so if we understand the structure here, it should help us relate to the structure for the given expression. So maybe drawing a sketch. So what do I want to see on your test? I need an explanation like this, but I also need a picture of a graph that shows that you understand what the expression is telling you. All right, your next video will cover problem 6 and 7.